In this video, we want to look at finding the inverse for a 3 by 3 matrix. So that means we need to first start off by seeing this as this larger matrix where you have A on one side and you have its identity on the other side. Well, since we have a 3 by 3, this guy's going to be a 3 like this. Okay. So we start off by writing A, so it's 1, 2, 1, 0, negative 1, 3, 2, 1, negative 4, and on the other side we write the identity matrix, so it's 1, 0, 0, 0, 1, 0, 0, 0, 1. And our goal is to, by using Gauss-Jordan method, we're going to get the identity on the left side, basically do the reduced row echelon form on the left, and what we're going to see after we do that is you'll have the identity on the left, you'll have the inverse on the right half. All right, so a couple of things that we can do here at the beginning. You already have a 1 and a 0, which is good, right? So we could very easily get this guy down here to become a 0. But I also see that I have almost a 1 here, but I've got that pesky negative. So I'm going to get rid of that negative, and I'm also going to get a 0 down here. So first, we're going to do negative row 2 and put that back into row 2. And then I want to do negative 2 times row 1 plus row 3 and put that into row 3. So these operations are totally separate from each other, so I'm okay doing this at the same time. So the first row doesn't change, so let's make sure we copy that down. In the second row, we're just changing the sign of everything, so it's positive 1, negative 3, then we have 0, negative 1, 0. All right, now we're going to do negative 2 times 1 plus 2, 0. Negative 2 times 2 plus 1 is negative 3. Negative 2 times 1 plus negative 4 is negative 6. But we still have to do that over here. So negative 2 times 1 plus the 0 is negative 2. And then you have 0, and you still have the 1. Those other guys won't be affected because you just have zeros in those other two entries. All right. Well, the next thing is that we need to get this guy to be a 0. Because we already have the 1s going along the diagonal. That's good. We need to get a 0 underneath this next leading 1. So we'll do 3 times row 2 plus row 3 and replace row 3 with that. All right. So it's kind of helpful to write all the stuff that doesn't change first. All right. Now, 3 times 0 plus 0 is 0. 3 times 1 plus negative 3 is 0. 3 times negative 3 plus negative 6 is negative 15. 3 times 0 plus negative 2 is negative 2. 3 times negative 1 plus 0 is negative 3. 3 times 0 plus 1, we still get 1. And then from here, we want to make sure that this guy becomes a 1. Easy enough. We'll just do negative 1/15 times row 3 and replace row 3 with that. So all we're changing is going to be that last row. Everybody else stays the same. So be very careful as you go from one line to the next. Don't change things. So we have 0, 0. This is now going to become a 1. And you're dividing everything else by negative 15. So it becomes a positive 2 over 15. Negative times negative is positive. 3 over 15 is 1/5. And then we have negative 1/15. All right. Now we're going to use this bottom row right here to get zeros here and here. And the way that we do that is we're going to do negative row 3 plus row 1, replace row 1 with that. And then we're going to do 3 times row 3 and add that to row 2 and make that replacement. All right, so let's see. Guess we only get to keep the bottom row the same this time. So that's 2/15, 1/5, negative 1/15. All right. So I'm doing negative the bottom row plus the top one. So negative 0 plus 1 is still 1. Negative 0 plus 2 is still 2. Negative 1 plus 1 is 0. Negative 2/15 plus 1 gives me positive 13/15. Negative times 1/5 plus 0 is negative 1/5. And then negative and negative is a positive 1/15 plus 0 is 1/15. Okay, that doesn't seem to be too terribly bad right now. Then we got this next part. We've got to do 3 times row 3 plus row 2. That's going to be a 0. That's going to be 1. 3 times 1 plus negative 3 is 0. Like we knew that was going to happen. Not a big deal. But now we've got to do this. We've got to do 3 times 2/15 plus 0. That's not too bad. That just reduces, gives me 2/5. So that's 2/5. And then we have 3 times 1/5 minus 1. So 3/5 minus 5/5 is negative 2/5. Negative 2/5. And then we have, well, I guess that's not too bad. 3 times negative 1/15 is negative 1/5. All right, I know it's messy, but we're almost done. We just have one more step, and that is to get that to be a 0. And we can accomplish that by doing negative 2 times row 2 plus row 1, and we replace that in row 1. Now, this should leave us with the 3x3 identity matrix here on the left. We did not change anything at this point for these last 2 rows. But now we will for the top one. So we need to do negative 2 times 2/5 plus what's in the top one above that. So that's 13/15. So negative 4/5 plus 13/15. Well, this guy becomes negative 12/15. So that's 1/15. And then we have so negative 2 times negative 2/5 plus the guy in the top, negative 1/5. All right, so that's positive 4/5. That's going to give me 3/5. And then we have negative 2 times row 2, that's negative 1/5, plus 1/15. So 2/5 plus 1/15. This becomes 6/15 plus 1/15, and that's 7/15. There is your inverse. What fun, right? Whew, that's a lot of work. Let's check it with our calculator. So we're going to edit our matrix. Let's just do this one, turn this into a 3 by 3. Our original matrix was 1, 2, 1, 0, -1, 3, 2, 1, -4. Now, previously, we've done that same operation. Turn that into, or find its inverse, convert to a fraction. Let's see what it tells me. 1 over 15, 3 over 5, 7 over 15. Yeah, amazingly, everything here checks out. Now, don't go too far because we're going to use this guy in the next problem. So please make sure you stick around for that.